Hey guys, this is lesson 9, and let's get started with some additions of unlike fractions. So we're asked to find the sum of the following fractions simplified, okay? So before we get into this, let's review. So how do we add two unlike fractions? What do we have to find? Well, we have to find the least common denominator, right? Remember that? Which is also known as LCD, right? Okay, so knowing that, let's look at number 1. So, as expected, we have two different denominators. And so what do we have to do? We are going to have to first find the LCD. And then, in this case, that's going to be 55. Okay? And then now, since we multiply 5 by 11, we're going to do the same thing on the top. So we get 44. And then for 11, we multiply by 5. So we're going to do the same thing on the top. So then 9 times 5 equals 45. Okay? So now, since we have the same denominator, now we can add the top. So 44 plus 45 equals 89 over 45. Okay? And then when we simplify that, we get 1 and 3/4 over 55. Okay? So let's move on to number 6. Oh, well, for number 6, we have the same denominator already. So we just got to add the top. So 2 plus 3 equals 5, and then just write the denominator, which is 7. So 5 over 7, that's it. Okay, so go ahead and finish the rest, and then let's move on to multiplying fractions by whole numbers. So here we are asked to multiply the whole numbers and a fraction, again simplified. So for number 1, here again, always remember there is a denominator of 1 for any whole numbers, okay? So for multiplication, do we need LCDs? No, we don't. That's for addition and subtraction, right? So we just got to multiply it across. So 2 times 3 equals 6, and then 1 times 10 equals 10. And then when we simplify that, we get 3 over 5, right? Because you divide it by 2, okay? So you're just multiplying the numerators by numerators, and then the denominators by denominators. Okay, so number 6. Again, remember there is a denominator of 1 for 10. And then you just multiply it across, which is 10 times 1 equals 10. And then 1 times 4 equals 4. Okay, and then you just simplify it. That becomes 5 over 2, and then that becomes 2 and 1 over 2. Okay. Again, finish the rest, and then let's move on to classifying angles. So here it says estimate the angle measures, and then identify if it is an acute, obtuse, or a right angle. Okay, and then the possible angle measures are given below, which are these. Okay, so to review, right angle is when we have 90 degrees. That's a 90-degree angle. Acute is when the angle is smaller than 90 degrees. Okay. And then obtuse is when it's larger than 90 degrees. Okay. So for acute angle, the 90 degrees would be over here. So then it's smaller. And then for obtuse, the 90 degrees would again be here. So then it's larger. Okay, that's smaller, and then this is larger. So let's look at the example. How do we know that this is a 45 angle? Well, we know how 90 degrees look like, right? That's 90 degrees. And then this angle seems to be the half of 90 degrees. And we know that that's 45 degrees. Okay, and then we know it's an acute angle because 45 degrees is less than 90 degrees, right? So let's look at number 1. Here again, we know how 90 degrees looks like, okay? And then this angle then seems to be smaller than 90 degrees, right? So let's look at the possible measures, angle measures. So it's for sure not 90 degrees because we know how 90 degrees looks like. And this angle doesn't look like one. It's for sure not 155 degrees because it's not an obtuse angle, it's an acute angle. It's so therefore it's not 170 either. Is it 35 degrees? Well, no, because why? Because we know how 45 degrees looks like. And then 35 is going to be smaller than 45 degrees, right? It's going to be somewhere over here. So no, it's not going to be 35. So what are we left with? Well, we're only left with 80 degrees. So our answer is 80 degrees. 80 degrees, acute angle, right? Because 80 degrees is less than 90 degrees. Acute angle. Okay? So, give number 2, 3, and 4 a try. Then let's move on to our last page, which is proportions word problems. So for number 1, a car travels 120 miles in 3 hours with a constant speed. And then, so how far will it take to travel? Oh wait, I think that was supposed to be how long. Okay, because we're gonna have to find hours. So how long will it take to travel 200 miles? Okay, well, here we are going to set up, we are going to set up a ratio. So 100 to 20 miles in 3 hours, right? And then how many hours are we going to travel? Wait, sorry, that's not there. How many hours are we going to travel? And then we're going to call it X, right? Because we don't know. So how many hours are we going to travel in 200 miles? Okay, so we're looking for this X. Well, here, no, we're just going to cross multiply. So that's just 120x equals 600, right? So just isolate x, divide both sides by 120, and then we get x equals 5. Don't forget the hours. Okay? So what does that mean? That means we're traveling, we can travel 200 miles in 5 hours. Okay, so last question, let's look at number 5. A machine can produce 6 yards of fabric in 2 minutes. Then how much fabric can the machine produce in 1 hour? Okay, this is tricky. Why? Because we have 2 different units. Can we do that? Can we set up a proportion like that? No, we cannot. Okay, so either we have to change minutes into hours, or hours into minutes. And we're going to change hours into minutes. Why? Because we know for a fact that just 1 hour is 60 minutes, right? It's just that simple. So we're going to change hours into minutes. So again, let's set up a proportion. So we're producing 6 yards of fabric in 2 minutes. Then how much fabric how many yards of fabric can we produce in 1 hour, which is 60 minutes, right? So again, just cross multiply. So 6 times 60, 360 equals 2x. Isolate x, divide both sides by 2, so x equals 180 yards. Okay. So what does that mean? That means we're producing 180 yards of fabric in 1 hour. Okay? So hopefully that wasn't too hard or too confusing. And here are your answers.